Hi there, we are Team IS23. We'll be describing and explaining our poster in this video. Our project is about the obfuscation of malware by hiding them in images, or as images, using various image embedding and steganography techniques. The goal is to investigate these techniques and establish their effectiveness in bypassing antiviruses by uploading the malware-infected image to VirusTotal. VirusTotal is a free web-based tool that hosts 70 antivirus scanners. The team also studies the changes to the antivirus detection rate by further obfuscating the malware at assembly level, or with encoding and encryption techniques. These techniques are applied before hiding the malware into an image. For this project, we look specifically at JPEG and PNG file formats, and we focus on Windows-based malware. One of the project's deliverables was to programmatically implement the different obfuscation techniques. Thus, the team has produced two tools, MIST, our Embedding and Steganography tool, and Neo, our .NET Assembly Obfuscator tool. The technologies used for these tools are Python and .NET. Both MIST and Neo are command line interface tools. MIST, our Embedding and Steganography tool, has two inputs. It takes in an image and an executable and hides the executable into the image. The output is a malware-infected image file. Users can choose the obfuscation technique they want MIST to use and specify any optional encoding or encryption module to apply to the malware before it is hidden into the image. MIST supports 5 embedding techniques, 5 steganography techniques, and 3 encoding and encryption techniques. The difference between steganography and embedding techniques is that stego breaks up the malware data into various bits, whilst embedding keeps the malware data whole, only breaking them down into sections of bytes if necessary. Neo is our .NET Assembly Obfuscator tool and is used in conjunction with MIST. Neo works with .NET Assembly files. They are known as intermediate language files and are obtained by disassembling a .NET application. Bear in mind that these IL files can be reassembled back to .NET executables. Neo takes in an IL file and runs 6 obfuscation modules against it. The output would be an obfuscated IL file, which can be reassembled back into an obfuscated executable. The user must manually disassemble and reassemble the .NET executable. The 6 obfuscation modules aim to deter signature-based antiviruses. These techniques do everything from adding junk code to scrambling the names of the malware functions. The obfuscated .NET executable from Neo can be inputted into MIST, further bypassing more antiviruses. The VirusTotal Results details the efficacy of each obfuscation method. As the antiviruses on VirusTotal update their databases frequently, the team conducted progressive testing to ensure the accuracy of the results. The samples were uploaded twice per day over the course of 5 days. The team has used 3 malwares to test the efficiency of MIST. This is the EXE group. Another 3 malwares are used to test the efficiency of Neo. This is the .NET group. Neo requires another set of malware as it only works with .NET executables. The baseline antivirus detection rates for each malware are as shown. For MIST, the average detection rate is 43. For the .NET group, it has similar results. After Neo, we can see that the detection rate has fallen, and the average with Neo is 33. The first table showcases the performance of the embedding techniques with no extra encryption. The rates across the 3 malwares are summed and averaged. For all of these methods, there is a huge decrease in detection even for the simplest methods, like appending the malware file to the back of the image. The most effective obfuscation method here is chunk insertion between image data, having 0 detections when it is paired with Neo. In total, the detection rates are reduced by 65% to 95% for this table. This table shows the results of embedding techniques with the additional encoding modules in MIST. Comparing the two tables, we can observe that with the use of simple base64 or XOR encoding, the detection rate plummets once again. With Neo, the results are slightly more favourable. In total, the detections are reduced by 90% to 95% for this table. Finally, this is the image steganography results. They are much more stealthy than the embedding methods, and they have achieved 0 detection rates across all the malwares.